So today we're going to be dividing complex numbers, and division problems can be rewritten as what? It can be rewritten as a multiplication problem, but if we still keep it as division, what else can it be written as? Or what can it be thought as? Fractions. That's what it is, yeah. Division problems are just fractions. Okay? So, there's a couple of things that we need to remember about fractions as far as our final answers go. I'm just going to kind of put it down here. There are a few places where we need to be careful when dealing with fractions. Okay? One such place is if we have, and we saw this when we dealt with the quadratic formula, if you have a negative in the denominator. I don't want that negative there, right? We either want the negative out in front of the fraction or in the top of the fraction. Okay? And that's not really a rule in math. I mean, the higher up in math you go, the more you might break that rule. Because it's really not a rule. It's just a common practice. Why is it a common practice? Because it helps us find a common denominator if we're going through and adding a bunch of fractions together, right? If some are positive, some are negative, it gets to be a pain to find that common denominator. So we just always make the denominator positive. Okay? That's what it is, the convention of that. Another place where we have issues is if we have a fraction that has a square root in the denominator. Well, in that particular case, and we dealt with this a little bit, we haven't done this a lot yet, we then rationalize. Some of you told me you remember doing that from Algebra 1 and from geometry, that you rationalize the denominator, which means you would multiply the top and bottom by, in this case, the square root of b, okay, to get rid of that square root in the denominator. So we don't want square roots in our denominators for our simplified answers. And the last place where we run into issues is going to be dealing with imaginary numbers in the denominator. We don't want those there either. Okay? So these are currently our three issues in fractions. All right? We never want a negative in the denominator, a square root in the denominator, or an imaginary number in the denominator. Well, we now need to know how to deal with that. So that's where conjugates come into play. Okay? That's where conjugates come into play. Now, conjugate is just a $1,000 word that really all it means is that we change the sign in a complex number. Okay? So, for example, here they have a plus bi. There's our complex number. The conjugate of that is just a minus bi. Okay? Notice the a didn't change. A does not go from positive to negative. The only thing that changes is the sign in the middle. Okay? That's a conjugate. Why do we care about conjugates? Well, it says right here, the product, which by the way, what does product mean? Product means an operation. What operation? Multiplication. Okay? Multiplication. So the product or multiplication of complex conjugates gives us a real number. Okay? So if I take a number, and I'm just going to write it off to the side here. If I take a number such as negative 4, let's make that minus 2i. So negative 4 minus 2i. There's my imaginary complex number. Okay? What would then be the conjugate of that? Again, do I change the real number out in front? Do I change that a? No. I only change the imaginary part. So what's the conjugate of negative 4 minus 2i? Negative 4 plus 2i. Okay? That's the conjugate. What's the point of that? The point of that is that if I multiply these two together, I'm going to end up getting a real number. Okay? That's the point of the conjugate. So if I multiply a complex number times its conjugate, I'll get a real number. All right? Okay, now let's see where that's going to be used. So to see where that's going to be used, let's take a look at number 4. Okay, number 14 here, we have 5 plus 2i all over 4i. Now, 4i, that's a pure imaginary number. That's not a complex number. That's just a pure imaginary number. But if I put the real number out in front of it, what would the real number be? What would the real portion of that complex number be? 0. 0. This would be 0 plus 4i. So then what's the conjugate of this? 0 minus 4i. Okay? Now, since I don't need to write the 0 part, the conjugate is just going to be negative 4i. And we're going to multiply the top and the bottom by that conjugate. Okay? We're going to multiply the top and the bottom by that conjugate. Now, do you know why we multiply the top and the bottom by that?
Because what you do to one side, you have to do to the other.
Okay, but that's the rule. What you do to one side, you have to do to the other. That's the rule for equalities. We don't have an equality here. No? I like to think about this as taking a fraction and putting it in a Halloween costume. Okay? When you put on a Halloween costume, are you a different person? No, you're just you in a Halloween costume. Right? Okay. So it's the same thing. Let's keep it simple here. Let's talk about like 1/2. If I have 1/2, okay, and I want my denominator to be an 8, I got to multiply the bottom by 4. But I can't just multiply the 2 by 4 because 1/2 and 1/8 are not the same thing. So I multiply the top by 4 as well because 4/8 is the same thing as 1/2, right? What did I do? I went through and multiplied 1/2 by 1. Okay? 4 over 4 is 1. So I took 1/2, multiplied it by 1. Okay? I took 1/2 and I put it in a Halloween costume. It's the same thing, it just looks different. It's now 4 over 8. Okay? That's the whole thing with fractions. If you want to change what a fraction looks like, you can do that. But you can't change the value of the fraction. Okay? It still has to be equivalent to what it was originally. And so that's what we have here. We have a fraction. We have a fraction that we want to multiply by 1 to change what it looks like. All right? That's why we do that. That's why we do that. So we keep the value of the fraction, but we change what it looks like. In our case, we want to get rid of the imaginary in the denominator. So taking multiplying on the top, we actually have to distribute. So negative 4i times 5 and negative 4i times 2i gives us negative 20i minus 8i squared. And on the bottom, what do we get? But we don't need that 0 there, right? We're just taking 4i times negative 4i. Negative 16i squared. Excellent. Okay. Now we also need to simplify again because we have I to a power. We never want I to a power. Okay? We don't want I squared or I cubed or I to the 4th or I to the 5th. That's why we learned yesterday the rule of I's. What was the rule of I's? Not I win. I won. I won. Negatives in the middle. I won. Negatives in the middle. So what does that tell us? That tells us that we have I won. Negatives in the middle. That gives us I squared, I cubed, and I to the 4th. We're dealing with I squared. I squared is negative 1. All right. So we have negative 20i plus 8 over 16. We want to make sure that our answer is written as a complex number. Okay, we want our answer to be written as a complex number. So what we need to do is break that apart into two fractions. All right, so I've got negative 20i over 16 plus 8/16. There's an issue here. Well, a couple issues. First off, we haven't reduced yet. Okay? But the other issue is, in a complex number, what always comes first?
The real number.
The real number always comes first. So I've got to flip-flop this. I'm not only going to reduce 8/16 to what? 1/2. But I'm going to make sure to write it out in front. So I have 1/2, and then negative 20i over 16. What does that reduce down to? Negative 5/4, yeah. 4 goes into 25 times, goes into 16 4 times. And so negative 5i over 4, I'm writing that as negative 5i over 4. So now we have our real number, the real portion, and the imaginary portion of our complex number. And if you really want to get fancy, you can write it like this. 1/2 minus 5/4 I. Okay? And that's the answer. Yep. Answer written two different ways. But yes, that's the answer. 1/2 minus 5/4 I. That's a complex number. That is our solution to that original division problem. Okay? Questions? Nothing yet? Let's try another one. 15. Now remember, the denominator is the issue, right? The denominator is the issue. We don't care about what's in the numerator. We can have complex numbers in the numerator. We can have square roots in the numerator. We can have negative numbers in the numerator. We can't have those in the denominator. So when I multiply top and bottom by something, it's always the conjugate of the denominator, the number on the bottom. Okay, so what is the conjugate of 4 minus 3i? 4 plus 3i. All right, so we're going to multiply top and bottom by that, which means we have to do a lot of FOILing. All right, so on top we have 3 times 4, 3 times 3i, negative 2i times 4, negative 2i times 3i, over 4 times 4, 4 times 3i, negative 3i times 4, and negative 3i times 3i. We can go through now and do some reducing. Oops, and I apparently forgot to write a squared here, right? That should be negative 6i squared on the top because it's negative 2i times 3i. Yep. Okay, so now I want to reduce the I squared there and the I squared on the denominator. Also, what happens with the 12i minus 12i? Cancels out. 12i minus 12i goes away. Okay, and again, the whole point is to get rid of the imaginary number in the denominator. That's what we're trying to do. So, on top, we have 12 plus 6, because that's negative 6 times negative 1. So 12 plus 6, 18. Now we have 9i minus 8i. I. Positive I. Plus I. Over, on the bottom we have 16 plus 9. 16 plus 9? 25. Yes, ma'am.
It's 12 plus negative. Oh, because the 6 and the negative.
Because negative 6 times negative 1 gives us a positive 6. I just didn't rewrite it. But yep. Okay. All right, so we're almost done. We're almost done. I'm going to rewrite my answer here in proper complex number form. So I have 18/25 plus 1/25 I. Now remember, had you left that I over 25, same thing. Can we? What goes into both 18 and 25 evenly? So yeah, we should reduce if we can. Yeah, we definitely should reduce if we can reduce, and in this case we can't. So we're done. Questions on 15? The I's not on the bottom. The I's out on the side. It's 1/25 I. Because there was a 1 up there to begin with. If you have I over 25, that's the same thing as saying 1/25 times I. Because I can put I over 1 and then multiplying fractions, say multiply across the top and multiply across the bottom. Nope. Same thing. Yep. I over 25 is the same thing as 1/25 I.
Do you have to split it
Into two separate fractions? Yes. Yes, your answer has to be split into two separate fractions because written like this is not written in proper complex number form. A complex number always has the real number written first, plus or minus the imaginary number. Okay? Any other questions? I want you guys to try one on your own. Why don't you guys do number 16? Ready, go. Okay, so first off, we should have all went through and multiplied the top and bottom by the conjugate, which in this case is -2 minus I. -2 minus I. Because remember, all that changes is the plus or minus in the middle, not the number out in front. Okay, so that -2 stays -2. So on top, we have to distribute. On the bottom, we're going to have to FOIL. So on top, 3I times -2. Anyone? -6I. 3I times -I. -3I squared. On the bottom, we have -2 times -2. +4. -2 times -I. +2I. I times -2. -2I. And I times -I is a -I squared. We don't want I squareds in our answer because I squared equals -1. All right, so now on the top, we want our real number first, right? So on the top, take -3 times -1 to get +3 minus 6I over. Now on the bottom, we have 4 minus a -1. Or what? +1. -1 is +1. So this is 4 plus 1. And then +2I minus 2I, those cancel each other out. So our answer should be 3/5 minus 6/5 I.
If you flip 3 and -6I around, same thing.
No, the imaginary number always has to come second.
Okay, yeah.
The imaginary number always has to come second. Questions on number 16? No? All right, then we have one more to do. Let's take a look at number 17. We'll work this one together quickly. We're going to multiply the top and bottom by the conjugate. What is the conjugate? 5 plus 2i, because it's always the conjugate of the denominator. So this is 5 plus 2i. And so on the top, we have to distribute the 7. On the bottom, we're going to have to FOIL, which means we're taking 5 times 5, 5 times 2i, negative 2i times 5, and negative 2i times 2i. So we should have 35 plus 14i over 25 plus 10i minus 10i minus 4i squared. I squared is negative 1. So really we have what back there? Plus 4, right? So on top we have 35 plus 14i over 25 plus 4 is 29, and plus 10i minus 10i cancel away. So this is going to be our answer. We just need to make sure to write it as a complex number. So 35 29ths plus 14 29ths I. And that's our final answer only because we can't reduce that, right? If we were able to reduce those fractions, you definitely would. Okay? Any questions? Any comments? None. Okay, let's talk about homework.